Hello, today we're going to do Module 6, Lesson 6. We're going to interpret measurement data from various line plots. Please pay attention that there are two templates needed for this lesson. You can take your notes on your templates that are stapled to your homework page, and I will give you that credit for those notes. Okay. Please look at the first template. It says it's a graph and it says number of miles a truck driver drives. On the side it has number of miles and on the bottom it has days. Now I obviously didn't put in the bars because I'm going to do the bars with you. So let's look at that. The very first day, I want you to notice there's Monday, Tuesday, Wednesday, Thursday, Friday on your template. But there's a couple odd things about it. So for instance, if you look at let's put our scale on our graph. So here I have 50, here's 100, here is 150, 200, 250, 300, and then up here we could be 350. Now your scale goes all the way up to 500. I'm not going to go all the way up to 500. Now, I need to get a finer pencil, because if you notice, how many lines are there in between like 0 and 50 on your scale? There's 4 little lines. And there's 4 little lines here. See that? What do you think each one of those lines stands for? Do you think it stands for 1? Well, how many miles is in between each big line? What do we have? Between each line is worth 50, right? So we count it by 50. So I got to break it down to figure out what each one of these are. So let's look at this. Could it be 5s? If I count it by 5s, 5, 10, 15, 20, 50, no, that can't be it. Should we try 10s? 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Ooh, they're worth 10. So each one of those lines is worth 10. Okay? So whenever you see a scale and it has lines like this, you got to figure out what those lines are. They may not tell you. They may assume that you can figure it out just by knowing that there's 50 in between each big line. Okay, now that being said, get me in my line. Let's look at Monday. So here, I'm going to do Monday right here. I'm not going to do all the days, but let's go Monday. Monday goes clear up to up here, and then they've gone all the way down. Now notice that my graph is not as tall as your graph, and that's okay because I'm not going to cover the entire graph, just parts of it. Okay, so all of this is shaded, but you're going to notice there was a dotted, there's a dotted line right here. So this shows that it's not all the way up to the line. It is, however, up to this line, and this line would be what? Well, if each one of these is worth 10, this is 300, this would be 310, 320, 330, 340. So how many miles is it from Monday that they traveled? 340 miles. Okay? Let's look at Thursday. So skip over to Thursday. Now Thursday is right here, and then they have it drawn down, and this part shaded in. Okay, but right here they have a dotted line to show you very clearly it's not all the way up to 200. It is on this line. That being said, how many miles would that be? Well, this is 150. Let's count by tens. 160, 170, 180, 190. Or instead of counting up by tens, we could say 200 and go back 10. 200, 1 less, or 110 less would be 190. Whoops. So Thursday is 190 miles driven. Okay, those are the two ones that I really wanted you to pay attention to. Because this means that we don't always have to have the answers fit on the main lines. We can show a graph that shows more accurate answers, more realistic answers, by using the scale. All right, next. This is our application problem. on the bottom or someplace on your papers or behind your templates. Let's do this problem. Caitlin measures the height of her bean plant on Monday and again on Friday. She says that her bean plant grew 10 quarter inches. So her partner records 2.5 inches on their growth chart for the week. Is her partner right? Why or why not? Well, I just don't know if she's right. So let's do a number line. And let's do some quarter inches. Okay, so if this is 0, let's count here. So this would be 1, 2, 3, 3, 4. Now let's put some quarter inches here. So this would be half. Let's mark our quarters. Quarters mean fourths. So I'm going to mark my quarters. Here's my half. Here's my quarters. Here's my half. Here's my quarters. Okay, now I'm going to change colors. Okay, so she said 10 quarter inches. Well, here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This right here is 10 quarter inches. Okay, so if that's the case, let's do a number line down here and let's see if that is the same as 2.5. I'm going to line up my lines because I want to be able to compare. It'd be like putting two rulers side by side. We want things to be accurate. Here's fourths. Then I put my halves. This one I need to mark into halves because she put 2.5. Now, is this right here the same? Because this is what her partner marked, 2.5. Is that the same? It is. So why is it the same? This is what we got to write. Yes, her partner is right. We figured that one out and we proved it. Okay, so yes, her partner's right. Now why? It asks why or why not. It is right because when I drew two number lines, cutting one into quarters and one into halves, and cutting one into quarters and one into halves, the points fell at the same spot. On both number lines. Let's write that. Okay, now let's look at what I wrote as soon as I can get done writing it. Waiting for my computer to catch up here. Okay, yes, her partner is right. It is right because when I drew two number lines cutting one into quarters and one into halves, the point fell at the same spot on both number lines. Now this is what I said that I did to find out why. And what is this? These are pictures showing what I did. Now you know that in class sometimes I will say I told you and I showed you to help you learn. So what have you done? You've told me and you've showed me. This is a good thing. This helps people learn things a lot better. Okay, moving on. Pull out your other template. And it has a plot diagram. Now this is actually, I'm going to extend this out. This is actually a number line if you notice. And right here we have shown different things. Now let's examine, whoops, things got a little bit mixed up down here, didn't they? Look how my numbers didn't quite line up. That's because sometimes things happen. This is a 1.5. This would be 2. This would be 2.5. This would be 3. This would be 3.5, and this would be 4. There, we fixed that. Now just don't pay attention to these, and don't pay attention to that diagram. They plotted it on a number line. So I can look at this number line and I can see that how many hours, or how much, it says time spent outside over the weekend. Each one of those X's is one person, so I know I'm counting. So clearly somebody has asked a poll to find out how much time people spent outside over the weekend. What was the most common time that was spent in the outside over the weekend? Well, that's going to be the one that has the most people that spent it. So that would be 2 hours. And how many people spent 2 hours outside over the weekend? 1, 2, 3, 4, 5, 6 people spent that. What was the least common time spent outside over the weekend? Well, I'm going to look to see which one has only one person who did it. And that would be right here. 4 hours was only spent by one person. And I can say, is there any amount of times, or any hours, number of hours that had similar amounts spent? Well, I can see that this one has 3 people and this one has 3 people, so I can say that 3 people spent 1 hour outside and 3 people spent 3 hours outside. Those were similar amounts spent outside. Okay? Using this information, we've used some new words. We've used common. We've used most common, least common, and similar, haven't we? Common and similar are kind of the same. So the most common hours spent over the excuse me, I have to get my brain together here. The amount of time spent that was most common among the people who were asked was 2 hours. The least common amount that was spent outside by the number of people asked was one person said 4 hours. And we had some similarities. We noticed that 3 people chose 1 hour and 3 people said 3 hours. So we had some similarities, some similar things. Using that, we can also say frequent. We can use less frequent, so we can use words to help compare. We can use frequent, we can use less frequent, more than, less than, to figure out what this data means. Your work today, you're going to be given a line plot like this, a plot graph on a number line, and you get to figure out what they're asking, what is being shown on that graph. It's kind of neat that you can use a number line and a graph to give some information very easily, very clearly. All right, good luck with your homework. I'll see you soon.